This is John from caveofprogramming.com. In this tutorial, we're going to take our very minimal SDL application here and we're going to set it up so that it produces a window, just a blank empty window on the screen, which you can close by clicking the cross in the corner. So the way I put this together originally was by searching for sample code on Google. I searched for stuff like SDL tutorial, and I found a tutorial that did the beginnings of what I want. I found several tutorials actually, which was to create an SDL program that runs in a window and does actually accesses the pixels, does pixel manipulation, pixel access. And then I took out the basic bits of that tutorial bit by bit. So first I worked on getting a window on the screen, and then I worked on setting pixels on that window, and so on, and I proceeded from there. So that's a strategy I'd recommend to you, and especially if you want to create a program that does something that you're not sure if you're going to be able to do, like create a sound, for example, then it's really good to look at some tutorials and first put together a really minimal tutorial that makes a sound. So let's get started with this. The first thing I need to do here, once I've initialized my program correctly, is use a function called SDL create window to create a window. Let's get rid of this init succeeded thing. So I'm going to type here, we need an object of type SDL window pointer, which I'll call window, and we're going to create that by using a function called SDL underscore create window, paying careful attention to the capitalization there. Now the first argument to this, and by the way, if you're using a newer version of SDL, this could have changed, but you can easily look up information about these functions, or for that matter look for more recent tutorials. For example, if I hover over this, we actually get some documentation, at least in this version of Eclipse, about the function. We get more if we actually don't have a syntax error there. And you can also just paste it into Google and you'll find the official SDL documentation plus a load of tutorials as well. So it's really handy to do that. So the first argument here is it's a string, it's just the title of the window. So let's call this particle fire explosion. Second argument, if I remember rightly, the second and third arguments enable you to position the window, and I'm going to use a special constant from SDL.h called SDL window pos undefined. So hopefully I've remembered that correctly, and if not, I'm going to have to check when we fail to compile this. Let's see if I can format that. Now the next arguments are the screen width and the screen height, and I'm going to have to refer to those again later in my program. So I'm going to create constants with those values. Let's put these at the top of main. Variables you try to declare as close as possible to where you need them, but often with constants you'll put them somewhere near the top of a function, or perhaps more often you'll make them static public members of a class, because you need to use them in multiple places. So let's say here const int screen width. I'll set that equal to 600. This is actually going to be the size of the window. Actually, let's make it 800. But I'm calling it screen width and screen height, just because I may well change this at some point in the future to run full screen. But it will in this program actually be the window size. So I'm going to paste that in here. I've chosen 800 and 600 because, well, it probably doesn't matter what size we create the window, but there are certain standard screen resolutions that computers used to use historically and that modern computers are usually capable of switching into. If you do decide to create a full screen program, you've actually got to get your computer to switch its graphics mode, and there's only certain modes that it can switch into. And those are things like 800 by 600, which is a standard sort of mode. So I'm gonna just pick that just because it's kind of traditional, and because if we made this run full screen, it's likely that our computer could support this particular resolution. And the final argument that we have to supply here to SDL create window is going to be SDL underscore window shown. And this is at this point in the create window, if we hover over it here, we can see that we can supply various flags for the last item that alter the window in various ways. And although it doesn't seem to say here as far as I can see, if you look at the, oh, it does actually, yeah, no it doesn't. If you look at the API document, which I just searched for, you can actually find that SDL window shown basically means don't alter the window, just create a normal sort of window. So that's what I want here. So I didn't put this together, I didn't figure this out by looking at the API document, I figured it out by looking at tutorials. But the API document will often help you. It'll help you to understand what you're typing. And it's really, really useful when you do this, if you look at tutorials, to type lines out by yourself. Because even if you don't completely understand what you're typing, it really helps hugely to get it into your mind. And it's kind of a way of pushing yourself to gradually understand the code if you actually type it out yourself. So that's why I always type stuff out myself rather than just copy and paste it wholesale from tutorials, especially like the second or third time I do it. First time I may be tempted to copy and paste, but typing out is really good. So now we need to check to see if that window is null or not, because if SDL window can't create a window for some reason, it will return null. So I'm going to say if window is equal to null. Null is a constant which is often used in C++. It's defined in standard lib.h, stdlib.h, which sdl.h probably includes, or else, if not, then it probably defines it itself, but it's common to use this with a lot of different APIs. So let's say if the window is null, we're going to call SDL quit, and we're going to return, let's say, 2. So usually if your program runs okay, you return 0, and otherwise you usually return like a positive integer to indicate sort of what's happened. And you will only see this return code if you run your program in some fancy way in your operating system that enables you to get the return code from the program. So it's not really that useful. But the main thing is just it's just kind of traditional to return a non-zero integer if your program fails, but it would still work if you just did return 0, and you're probably never gonna actually examine that error code, but you could. Now, if you look at the API document, you find that you can get more information about what went wrong if SDL doesn't initialize properly using SDL get error. So we could output that using cout. This, I presume, returns a string. Here it's being output using printf. Printf stands for print format, and that's actually an old C function. But old habits die hard, and C++ programmers often use printf when they probably should be using cout. In some ways, printf is nicer than cout, I have to say. Cout can sometimes be a little bit cumbersome. So this is actually worth learning about, but you can just copy this line and paste it in to your program if you want to, and you have to include stdio.h, standard input output.h, as well, if you want to use printf, or you could just use cout with SDL get error. But if your program isn't created, that will enable you to get more information about what went wrong, and potentially you can type that information into Google and try to find other people who've got that same problem. So if we initialize the window correctly, before we quit the program, we have to call SDL_destroy window, paying close attention, as always, to capitalization, because C++ is case sensitive, and we supply it with the pointer to the window object. And we should call that as well. Actually, yeah, I was going to say we should call it here, but that's wrong. If we can't create the window, course, we don't need to destroy it. That would be a very bad idea, probably. It may even crash if you pass a null pointer to this function. I don't know. But if the window is created successfully and we don't return here, we want to destroy it, which I guess closes it and maybe cleans up some resources, and call SDL quit, which again will clean up any resources that SDL is using. Now, this isn't quite enough to put a window on our screen, because at the moment we will just be creating a window and immediately destroying it, immediately going on to end the program. So I doubt that we'd see a window if we ran this. What we need next is we need our game loop. So in games, and you have a similar concept in graphical user interface, GUI programs as well. In games you have a thing called a game loop, which will be a loop that will run for as long as the game is running, and it will do stuff like in the case of this program where we're going to deal with a load of particles, we're going to update the positions or state of particles, the color or whatever. We're going to draw our particles, and we're going to check for messages or events, you could say. What messages and events are if the user clicks a window or presses a button when a window program is active, or does anything involving the window, clicks a button on the window or something, we say that raises an event, and some sort of data structure will be filled in with information about what's happened, and we need to call some sort of function that checks if any events are waiting to be processed, and we can then examine those events and see what they are. So an event is something that we say is raised by the user doing something most of the time, or by something happening involving a window. We'll see how that works in a minute. In GUI programs, you have a similar idea called the event loop, which again has to run a loop which processes your events, things that are happening in a window, as well as give the kind of subsystem a chance to update the window. If it's like hidden by another window or something, it has to be redrawn appropriately, and so on. Now, this is an infinite loop, the way I've written this at the moment. What I'm actually going to do is create a Boolean variable, which I'll call quit, and I'll set that equal to false. And I'm going to do this loop while quit is false, in other words, while not quit. Or I could say while quit equals false, or while quit while quit is not equal to true. Those are all kind of the same thing. So while quit is false, I'll do the loop. And that means that if I set quit to true anywhere in this loop, then that's going to make the loop quit, which is what I want. Because the next thing I have to do is this is going to execute as rapidly as possible, because we want to be able to update the positions of particles and redraw them as quickly as possible to create a smooth animation. So what I need to do every time the loop runs is not only update the positions of particles and redraw them, I also need to process the event queue. So in between one iteration of this loop and the next, it's possible, even though it's going to hopefully execute really quickly, like 30 times a second or something, it's possible that multiple things could have happened. And SDL provides us with a way of checking multiple events, one after the other. And we're going to do that in a loop, which is going to be nested within the game loop. What we're going to do here is we're going to say while SDL underscore poll events. So poll events here, it's not being resolved at the moment, because this is actually going to fetch the latest event, or I guess it fetches the first event in the queue of possible events that have built up since the last time we called it, and it fills in information in an object of type SDL event. Let's declare that. So normally, if I want to use something here, which I do, if I want to supply an argument to SDL poll events, which has to be the address of a variable, normally I would declare it as close as possible to this loop. But because I don't want to be constantly redeclaring this variable in effect when the loop executes, I'm going to declare it outside of this loop, just because I suspect, although I'm not sure, that may make my program more efficient rather than if I declared this within the loop, and C++ will be forced to constantly destroy this variable and recreate it every time the loop iterated. So we need to supply the address of this, whatever it is, to SDL poll events. So SDL poll events will fill in information about what events have happened since last time it was called into this variable. So for that reason it needs its address. So we're going to say address event there. I'm getting an error here. It's possible it's called poll event. There we go. Now you see, it may appear like I have an encyclopedic knowledge of SDL, but I really don't. The only reason I can remember this is because I've typed it over and over again in the course of writing programs recently, especially, and in the course of making these tutorials. I think this is the fourth time I've recorded this video because something went horribly wrong each previous time. This time I'm keeping my fingers crossed, so now it's stuck in my head. But as a programmer, you're not expected to remember a particular API unless you're working with it day in, day out for months or years or something. And indeed, I don't remember SDL that well, but I've somehow got this in my head now without even meaning to, because I've typed it so many times. Okay, so this loop is gonna keep iterating as long as SDL poll event returns true, and it's gonna do that as long as there's an event waiting to be processed. So when it finds an event that can be processed, it returns true, which keeps the loop going, and it fills in information about that event in this event variable. So every time we do the main game loop, which we hope will execute something like 30 times a second or even more, we're going to also loop through all the waiting events and process them. But the only one we're actually going to use in this tutorial is we're going to access the type member, which is some sort of public member variable of this event. I think it's technically a union, which we haven't looked at, but we can think of this as a struct. We haven't looked at structs either, but a struct is the same as a class. It's just that in a struct, its member variables are public by default, whereas if you don't specify public or private in a class, the member variables or methods are private by default. But sometimes, for the sake of efficiency, you want to be able to access directly member variables of a class or struct, even though that breaks encapsulation. Sometimes, especially in games, this is something that you do for the sake of efficiency, and that's what we're doing here. I meant to put event.type here actually, and we're going to see if that's equal to SDL underscore quit. Now the quit event is raised if you click whatever decoration on your window closes the window. So in Windows, if you click the cross in the corner of the window, that raises an SDL quit event, which we put into the event queue, which this will then retrieve, and we can then check and see, oh yeah, we've got an SDL quit event, it's time to quit the program. And we'll do that just by setting quit equals true, which will then terminate our outer loop, and then we'll go through to wind down the program. Let's see if this works. So let's build this. And I've done something slightly wrong here. What did I do? Redefinition of screen width. Oh yeah, I didn't spot that. I should have put screen height here. Apologies if you spotted that and were wondering what on earth I was doing. Well, it's hard to get through this without making some mistake, but hopefully I'll get there in the end. Sorry about that. So I meant to have this 600 by 800 by 600 pixels. Okay, this window. Now let's check if this finally runs. So I'm going to click run here, and it doesn't seem to like that. Let's make sure I built it, and we can run it. Wow, so that's a little strange. One thing you can do if your build gets into a tangle is go to Project Clean. That will delete your final program and all of your compiled object files, and sometimes that helps, and then you can build it again. Let's go to Build All, just to make sure it really is building everything. And let's, just to be doubly sure we're trying to run the right project, let's right click it and go to Run as Local C++ Application. And now finally we've got a window. So I don't know what the problem was there, but it's good that it came up, because I meant to show you this clean build thing. So it's just a blank screen, which I actually find quite exciting, because it's full of potential. Now we can begin to manipulate the pixels in this window. And you may hear my computer working a bit. That's because, unlike a normal graphical user interface program, which will spend a lot of time harmlessly idling, so not using up CPU, a game like this, let's click the cross in the corner of the window here so it quits. A game like this will, as I say, it will try to update everything as often as possible. So we've got this loop executing frantically in here, and that's why, even though we're not doing anything, you hear perhaps my computer's fan struggling a bit. So I think that's it for this tutorial. Yeah, as I say, the Project Clean, if we talk about cleaning a build or doing a clean build, and that means deleting all your compiled objects and your final program, your .o files, and then recompiling. So you need to clean it and then go to Build Project, and sometimes that will help you get out of various tangles. So that's it for this tutorial, and in the next tutorial hopefully we'll get actually something drawn on this window, like at least some pixels, or maybe a solid block of color or something like that. So until next time, happy coding.